Hello, everyone. My name is Camden Glenn. I am a senior at Doane University. And for my senior research project, I decided to do an analysis on the history of probability and statistics. So, the goal of this project was to explain how different people, events, and concepts have shaped the disciplines of probability and statistics, and explain how these developments were important to to the importance of probability and statistics in the field of mathematics as a whole. So during my research, I was able to break apart the history of probability and statistics into three different timelines. The first one being the origins, decline, and preservation of probability and statistics. The second being the revival, and then the creation of the foundations and building blocks of what would be probability and statistics. And the third one being the dawn of modern statistics and where these disciplines are in relation to the field of mathematics as a whole today. The color coding will be on the following slides, and they will let you know which time period we are in based on which slide. So the origins of statistics goes way back to ancient Xia China and city-state Greece, where statistics at that time was more of an applied administrative type of science where these states used census or they collected census data on their population in order to improve tax and draft efficiency within their countries. Rome took the application of statistics during this period to the next level, where they extended the application to from just collecting of information and the use of information on their people to improving the land administrative and division efforts. This would be important to the later feudal system in medieval Europe. But by the 4th and 5th century, a societal collapse happened, which ended up with the destruction of most ancient centers of learning around the world and the loss of most ancient knowledge and texts that had this information. Exceptions being in the Arab world, there was a scholarly culture known as the Ummahs, which preserved ancient Hellenic texts in various places in northern Africa. In Western Europe, Catholic monasteries preserved old Hellenic texts as well. And on the societal level, like from the average peasant to the noble, there was a fondness in gambling and games of chance in Western Europe. This would be important later. And the surviving Eastern Roman Empire, also known as Byzantium, survived as the main center of learning and knowledge for this period and preserved the most amount of texts from what I could discover during my research. However, with the fall of Byzantium in 1453, a migration of these texts and their scholars to the West, mixed with the existing monastic groups and the various people that were interested in understanding the games of chance and gambling that existed in Western Europe. Some of these early people, such as Pascal and Fermat, tackled this challenge and they created concepts like Pascal's triangle, binomial expression, and coefficients, which would be important foundational tools towards probability for other mathematicians later on. But progress during this period was stagnant, to say the least, considering that many of these mathematicians were actually persecuted by the Catholic Church at the time. Their charge was the sin of usury, which basically says that if you are knowingly taking advantage of people in whatever shape or form, like you're extorting them or something like that, then it is sin to do so. And the fear from the European Church was of these mathematicians was that if they're starting to get a better understanding of these games of chance, this gambling culture, then they could take advantage of the various people, and therefore that was viewed as a sin. So it wasn't until about the 17th century when Abraham de Moivre came around that there started to be more regular progress being made because more people started getting involved in actually working on probability, especially when Abraham de Moivre developed the classical theory of probability, which is the theory of probability that we have today, actually, but it's essentially defined that probability is about measuring the likelihood of something happening, and that every probability experiment contains elements and outcomes that are equally likely. So with this formal theory in place, people like Thomas Bayes eventually started building their own concepts and contributing to the practice of probability at this point. Thomas Bayes was most known for the following concepts above, but his work was somewhat controversial, really. It conflicted with the mainstream probability theorists at the time for the following reasons. His work combined fixed data with known probability distributions in order to get an answer. And this data had both observed and unobserved data within it. As a result, you had multiple answers based on the assumptions. Most mainstream theorists, known as frequentists, discarded this, and they say that a probability is determined based on the frequency of an event or a certain piece of data being showing up over and over again. And at this point in time, we have the first major divide in the probability and eventually statistical community between what will be known as the frequentist and Bayesian theories. In a modern sense, it could be seen as like sports teams, like in baseball, the Red Sox and the Yankees going at it. We got two different fans here, and they're rivals and constantly trying to prove the other one wrong. For most of the time, for most of this time period, though, frequentist theory would remain dominant, but that would change later on, as I will discuss. So, following the divide between frequentists and Bayesians, the next mathematicians that are most important to the development of statistics and probability at this point is Francis Galton and Karl Pearson. Now, both of these individuals were eugenicists, which eugenics was essentially a science that sought to prove that ideas like selective breeding was important to the betterment of mankind, and people and eugenicists sought to improve the study of that. And where they saw a tool to kind of help in their research was probability and statistics. So they believed that probability and statistics was important to proving that eugenics worked and that it was right. And that is why eventually these people, particularly Karl Pearson over here, would eventually become known as the founder of the modern discipline of statistics, where he created a set of practices together with various other mathematicians, namely eugenics or eugenicists, and to help bridge statistics and probability to other sciences, namely eugenics, but other things as well, such as chemistry, physics, so on and so forth. But despite these people's works, they were never really recognized by the scientific community as being almost legitimate mathematicians, and that their contributions to a formalized theory was not absolute. That would come into play with later on with Karl Pearson's student, Sir Roland Fisher, who was a strong critic of both the frequentist and Bayesian theories. He mainly criticized frequentists for disregarding what he saw to be the importance of conditional probability to statistics, and he criticized Bayesians for the use of unobserved variables within statistical experimentation. Now, the thing that made Roland Fisher different from his predecessors was that he formulated a statistical theory known as the modern theory of statistics that was officially recognized, or at least eventually officially recognized, by the scientific community. And this theory created a distinction between samples and populations. It created a formalized system of practice for collecting, analyzing, and verifying conclusions on data samples and populations. So any statistical experiments, you had a formalized system now of collecting your information, doing an analysis or test on it, and then verifying your conclusions. And it created a focus on specifying, estimating, and distributing those samples to different types of interpretations of the same data. And while this was important to the field of statistics, it was not recognized right away by most statisticians because he was a deep critic of both of the mainstream theories. So it wasn't until a person known as Gertrude Cox, who was an influential member of the American Statistical Association and the Royal Statistical Society of Britain, who supported Roland Fisher, that his work would eventually come to recognize. Gertrude Cox was responsible for the spread of his work outside of Britain, considering that he didn't have much support for his new theory within Britain. And she was important to the integration of it into the American education system and the adoption of it abroad eventually, because of her spreading the importance and eventually popularizing Fisher's theory. And if it wasn't for Gertrude Cox, Roland Fisher would probably never have been recognized as the father of modern statistics. And with the spread of Fisher's work, we have the second divide in the probability and statistical community between the Bayesian theory, frequentist theory, and what would now be known as the Fisherian theory. And with the introduction of Fisher's theory, it broke the almost monopoly like stance that frequentists had on probability and statistics. With the increasing popularity of Fisherian and Bayesian theory after this point, various hybrid testing methods and concepts started coming out. Now, the ones I have up here, I'm not going to go through all of them, but one example of a hybrid testing method that was used and that was eventually developed after this was the empirical Bayes, which used frequentist data and reasoning to prove a Bayesian assumption and justify a Bayesian conclusion to an experiment. And an example of a hybrid concept is conditional frequentist, which reported data-dependent error probabilities within an experiment, regardless of which theory was used, and it was used to support the evidence that was in the data during that respective experiment. So with the spread of these hybrid concepts between the different theories, we have mathematicians like John Tukey and David Blackwell, who also started to, like Carl Pearson and Francis Galton attempted to do, bridge the practice of statistics to other scientific fields like engineering, computer science, physics, so on and so forth, that statistics or statistical methods are used in today. So in conclusion, the first part of our timeline, we start with statistics being an administrative science used mainly in states to help with improving their governing system. By the 4th and 5th century, a lot of this information and practice is lost. Eventually, with the migration of old texts from Byzantium to the West, a revival begins happening. Abraham de Moivre formulates the classical theory of probability, which is important for later which was important for later mathematicians like Thomas Bayes and his work, but would ultimately create the first divide between Bayesians and frequentists. Eugenicists like Carl Pearson would become the founder of the discipline of statistics.